What does it mean?
developers to get.
API first.
API first just means that you write your API, and then from that you build your, let's say, your service code or your client code.
Okay.
But you start with the API instead of, a lot of times these days, or in the past, the traditional way of doing it is you would start with your service code, and then you would kind of create APIs that give you access to the service code, and then from that you would create client. And because of this, your API doesn't always match your service.
Will you say that this kind of customer first approach that Bezos wanted at AWS a long time ago, or Amazon?
Yeah, it could be, maybe that was sort of the precursors to the current API first movement, if you will. But it's such a hard thing to do. No matter how hard we try, even internally, like we can't get people to do it.
Really?
Oh. No, it's a totally different way of thinking. And developers, if I tell you that I need a service that gives me the weather based on inputs of dates and cities, right? The first thing you start working on is the code for how do you get the weather. And
Charles just guilty.
Yeah.
Or guilty as charged.
Yeah. When I say you, I mean the royal you.
Oh, I will
with
do that.
everyone.
I will
Yeah.
do that. You start playing and you start getting the data.
You get, and if you're like me, I never start coding without writing a hello world. So I would write a web page that just like returns hello world, and then or an API. It may not be a web page; it might just be a service. And then I would start to echo back what I gave it, and then and I would just kind of build from there as sort of how I like to code. But I never start with writing the API spec.
But this is interesting. Is that a generational issue? Is there something that laziness built inside a human being, or?
I don't think it's a laziness issue. I think it's a paradigm shift in the industry that may or may not ever happen. Depends on.
So it's been always like that people start from code.
Yeah.
And then someone like Bezos or others started, or you, I mean, for instance, started to say,
Well, the driver is that my spec doesn't match my service. That's the driver. And so when I want to consume your service, what's the first thing you give me?
API.
You give me the API spec, right? You don't give me the code. You never give me the code. In fact, most services are closed source.
Yeah.
So all I have to go on is the API spec. So if that doesn't match what your service actually does, then I'm going to do things wrong. And sure, for a weather service, it might be something simple because, it tells me it's raining, it's not going to rain. Big deal, right? Mm. But what if the thing that you didn't specify correctly in the spec is the thing that gives me cross-region backup on my data? And I think I turned it on and I didn't, and then an issue happens in my main region, and now I've lost all my data. Right, so you have data. Once you get into like data integrity type bugs, those are the worst ones you could possibly have.
What do you do in your organization to push for this paradigm shift, or what has been done by others? I mean, is that an issue that other people share with you? Maybe the most.
Yes, it's not just Microsoft that. Are you saying other people as far as like other companies?
No, in your organizations.
It's one of those things where it doesn't matter who I talk to, or you could probably go do this anecdotal test yourself. Ask people if they think API first is better. They're always going to say yes, because all of the things on paper just line up, right? If my code, imagine if my service code was automatically written, at least the skeleton layer, so like the controller layer, right? Not the repositories that actually do the work, but the controller layer is written automatically from the spec. Well, then I could never be in a situation where my spec doesn't match my code. And so you ask anyone, is that better? Of course they're going to say yes. But then when it comes to, okay, now I need to do my work, it's just unnatural.
Code first.
It's, I have no other way to explain it, because if everyone agrees it's better, why haven't we done it? And it's not a new concept. It's not like this is a 2024 thing. This has been around for 10 years.
Can we put forth an hypothesis that it's not super difficult to do that, right? But it requires some discipline at the beginning, because you need to think, you need to do some research on what APIs to do, what not to do. It blocks you from or slows you. You cannot just go coding, right? And maybe this is unusual for us, or
I don't know that it's so here's what I see as kind of the bottlenecks. It is, if you tell me that I have to write in this language over here, and the most common language out there is Open API, right? Or Swagger. Swagger is V2, Open API V3 is out. So depending on your organization, that's most likely what you're going to be using. So if I have to tell you that you're a Java dev, and you know everything about Java, and you can code whatever is required, but now I tell you, you have to go write in this other language that you may or may not have ever seen. You might have a cursory understanding of it. You can't debug that language. You can't run tests against that language. So it doesn't really fit a language from the perspective of how developers approach problems and think. But now you have to write in that thing. And the whole time you're writing in that language, the only thing your mind is actually doing is it's saying, well, what is the code going to come out to look like? And so now what you're actually doing is you're trying to reverse engineer that this is what I want the code to look like. So what do I have to put in the spec to make that happen? Right? So it's just a very unnatural way of approaching the problem.
but that's a problem that you give to the wrong person at this point, because that problem should be given to in other organizations, like when we work together at Expedia, we have product managers that know the market, know the product. They tell us what they wanted, sometimes even in a format, organized, structured form, and then we do the code, right? Should it be better if an architect or a product person would craft, maybe informally, the API at least?
Well, it's not that the spec is not technical, because the spec specifies whether or not I want a byte array or a string to int dictionary, or you have to shape every model that you want to represent what's ahead, what code should I be returning, 204, 201, 200. All of these things are very technical problems that the developer will know, and the developer will code when he writes his code, but it's not necessarily something a product manager would be able to spec out.
Interesting.
Unless you start to get, okay, you have technical product managers, sure, they might know, but now I think that just creates new communication problems, because now somebody wrote a spec, you're, again, with API first, you're auto-generating that skeleton layer, scaffolding layer, whatever you want to call it, of the code, and then you're asking the developer to fill in the logical functional bits, right? And now you have this, well, why is the scaffolding look like this? Why is this integer and not a long? Or why, and then the product manager goes, well, that's what we want, and then the technical dev says, well, if you do that, then we're going to have this issue, and you have this extra communication layer that I think is just slows things down even more.
Well, it might slow things down, but it might bring problems closer to the source, right? Closer to the... You have that discussion earlier and not later, when everything is done and someone asks, oh, why is that long? And then...
Well, it would actually be interesting. I've never been in a team that was trying to do API first that had product managers.
Okay.
So it might be interesting if you have product managers, maybe that would work out, and I just can't see it. But in what I do today, and like in Azure, the majority of the product management is more just direct customer interaction, and your customer is another dev. So product manager role doesn't fit as well as just devs talking to each other.
Let me clarify something. When I say product manager, I don't think about a college hire that just did the product management school.
Well, no, like
and comes there. I mean, maybe let's.
the hotel's product manager were very intelligent people, but they were product people, right?
But
they didn't
maybe
know.
a stakeholder, maybe another architect or someone in your team that takes the job. Okay, your job is to create the API informally, with diagrams to solve particular problems without coding. I mean, something like that. Someone that would create the API with technical knowledge, maybe it's too far-fetched. So I don't know.
To me, it's chicken egg. Either you have someone who doesn't know how to code, and so learning this paradigm is not as foreign to them, but then they lack the technical understanding of how to fill out the spec to the detail that's necessary to create the code. Or you have someone that knows how to code and then fits into that reverse engineering bucket that they're also gonna suffer from. So it's like you got one problem or the other. And by the way, for all I know, the whole industry is gonna flip in the next couple of years, and we're all gonna be doing API first. But this has been around for at least 10 years, if not more, and we still haven't done it. And it's just a very difficult problem to solve.
Yeah, good.
So, I don't know. But we have a working group that we meet every 6 weeks, and we kind of talk about, different high-level leaders in different areas of the organization. We all have influence in some way, and so if we can sort of push these ideas in small ways over time, we might make some headway.
Well, keep us posted.
We'll see.
API first problem solved. So let's go back to the beginning, to the origin. Okay, let's try to explain in 30, 45 seconds what an SDK is for Azure, especially for executives, for decision makers, for people that have been not in touch with the technology, with the details of the technology for maybe a decade or two, right? People used to think about an SDK. I have a tool, I have something. I load the SDK and I control a software or a machine with an SDK. How do I control a cloud with the SDK? And since we talk about the API, one would think, there are services over there. I can interact with the services via APIs, right? When I use APIs, when I use SDK, what's the difference? So again, we don't need to go into the details of the tech. We need to give tools to the audience on what problem each one solves.
So SDKs kind of have three flavors. There's probably more, but in general, there's platform SDKs, which are just curated sets of ways to interact with the platform, so be it Windows or Linux or whatever, and then or SDKs for phone OSs, etc. And then there's language SDKs, which are usually higher level structures that make life easier for getting started on doing different development tasks. And then there are service SDKs, which just give you a easy way to access service without having to deal with writing all of the protocol layer interface and all of the translation layer when you're translating the payloads back into some sort of data structure in whatever your language of choice is. And so those are kind of the three main ways that SDKs are used, and I deal with the service ones almost all the time, and in the cloud sense, it's almost always service SDKs that you're dealing with. So the cloud is some set of services. Azure is 250 plus services. There's data plane layer, control plane layer, and all of those have some sort of API. And having an SDK to be able to interface with those APIs just makes development a whole lot easier.
Okay. You touched a lot of fronts. Can we take a moment on data layer, control layer?
The easiest way to explain, there's a lot of technical things, and every cloud has a slightly different separation, but the easiest way to explain it is take storage. If I am creating a storage account and maybe modifying the position, the permissions on that account, that's the control plane layer. And if I'm uploading a file to my storage or downloading a file from my storage, that's the data plane layer.
Okay.
So using the service is kind of data plane, and managing the service is control plane. A lot of times people call it management plane and data plane, but I think industry is more control plane, but same thing.
So say I'm a CTO of a small company, small medium company, right? And I have a feeling that I need to use Azure or any other cloud for that, and to do something, right? So, and I hear that there is an SDK, but I can also go online on the portal, create resources, manage resources, and I have a small team of people. And how do I choose? Also, probably depending on the level of expertise of my people, right? Because so how would I start?
So when you're writing an application against, we can just continue with the storage example. In the portal, you can like upload blobs or files to your storage, but you're not going to have your customer go through the portal to download the thing, right? So if I have an application where I'm uploading a bunch of stuff and I allow people to have access to that, they need some other way to get at it, right? So I'm going to have an application that I've written, and when they open up a certain page, they're going to see those files that I've uploaded. And the way they know what files to display in the application is they would do a query against that storage account, and they would say, give me the list of files that are there. And then I can show those, and then the customer can press more buttons and do things like delete them or download them.
But this signifies with an HTTP request, usually, right?
Exactly. So the portal is great for you managing things yourself. It's really great for testing things out and trying stuff. But when it comes to any application that you're going to let your customers at, you're not going to give them access directly to your portal. So using an SDK through your application is probably the main way that you're going to do that.
So, but can you explain what's the difference between an SDK and the API when when I'm developing an application? When I use one or the other?
Yeah. So if you have the reason why you would build an SDK is to minimize the amount of code that you have to rewrite every time you want to do something. And sometimes you're not minimizing your own code. The people that usually write the SDK are the people that own the service. And they're doing it so that their customers don't have to write the same code over and over and over. So the storage team writes a storage service. They don't necessarily rewrite the code to access the API 20 times, but all 20 of their customers has to do that same thing every time. So the barrier to entry for them to be able to adopt your service is quite high compared to somebody who did provide an SDK. So it's kind of a level up thing within the industry. When one cloud provider provides a really nice SDK that makes it super simple to just immediately start uploading things, well then every other cloud provider must provide the same thing. So it's a convenience layer. And so what you do is you write a program that handles all of the HTTP layer or whatever your protocol is. It has conversions between some nice looking classes. So like in Java or C# you would have classes that represent the data structures that are going to be sent over the payload, over the wire. And you would have translation, so serialization and deserialization to and from those. So when you get a response back from the service, you deserialize that back into a nice, easy class to interface with. And this just makes the application developer's time much lower as far as getting started and getting access to that service.
So we can say that the SDK is built on top of REST, HTTP,
or whatever protocol, yeah.
And it's more comfortable, easier to use, lower barrier. Can we say that it offers the same level of control, of tuning of performance, or sometimes you need to go down and use REST directly?
It's a great question. So, because SDKs are written as a convenience layer, there's oftentimes a natural yet not necessarily good drive to sort of hide all the details. And because you want to make it simple, right?
Mm-hmm.
So if I want to upload a batch of files, a set of files, what do I want to do if one of them fails? Do I want to continue, or do I want to just upload all of them and then just tell me which ones failed so I can retry just those? There's a lot of like control bits you have in the API, and if I wanted to make a simple API, I would just take a list of files and I would make all those decisions for you, right? That's the simplest API. But you lose control. So there's this kind of natural instinct to make everything super convenient and remove complexity. But at the same time, once you get past the hello world application, you actually want that complexity in a lot of different areas. So there's a balance in your SDK that you have to strike as far as how much do you hide versus how much do you not hide. Or maybe you have two overloads, one with 12 parameters and one with only 1 or 2 parameters.
Which problems are good to move to the cloud? At what cost? For small, medium organizations, right? For people that say, maybe they're listening to this and say, okay, I have my small website, I sell, I don't know, tires, and I have something. It would be nice to, run a little bit smoother. Maybe I have 2-3 people that follow this website or service, and if I go to the cloud, will there be a bump that, for 6 months I need 10 people, and then boom, it runs by itself, or it will be, I'm too small, never go to the cloud, or...
I think it's reverse, and I don't know how qualified I am to talk about like when to go to the cloud, when not to go to the cloud, but I have some anecdotal ideas on it. I think the smaller you are, the more sense it makes to go to the cloud, because at some point you get in economies of scale when it comes to I need to host 200,000 servers. At that point, running a data pipe into the data center and having dedicated IP and having your own power source and all that kind of stuff starts to make sense, amortized over 200,000 servers. But if I have 10 servers, none of that makes sense. Like the cost amortized over those 10 servers is going to be so high I can get it cheaper in the cloud all day. And I don't have to pay for the people that manage it, make sure that it stays up and all that kind of stuff. So the smaller you are, the more sense it makes to go on the cloud.
Because you still need to patch the OSs, make sure everything works. If something goes down, hardware or software, your business is threatened, and you need to go there.
And you have
physically, you need someone to do that.
There's a whole set of employees that you now need in order to manage all of that. And again, amortize that over 10 servers, there's no question that cloud is better. Amortized over 200,000 servers, 1.2 million servers. At what point does it become, better? And then it's not necessarily like cloud, not cloud. It's what services in the cloud are still very valuable at what scale that my company is currently at. And there are multi-billion-dollar companies that use 100% cloud because they believe their core skill set is not technology. Their core skill set is a bank or selling travel or something else. And so why am I spending my resources on something that's not my core skill set? I outsource that. There's those considerations as well, that there may not be a size at which you host your own stuff.
So let's go back to SDK API. So you do API work for all the services or a subset of them?
So currently I designed the .NET control plane SDK for all the Azure services. I work on across all the languages in some capacity and across data plane and management plane in some capacity, but that's sort of the area that I designed. But we take an interesting approach on the SDK, because writing an SDK that's good, given all of the different criteria that you have around flexibility, ease of use, having full control without having all the complexity right there in your face, having all of the properties and methods make sense from just an English perspective. When I see a method called upload, it should upload. Like it shouldn't be named inappropriately. All of those kinds of things. That takes a lot of time, and you can't directly translate from a spec into a good API 99% of the time, because people don't take time to write good specs. It's back to that thing we were talking about earlier. So and
who gives you the spec?
The service owner, the developers. Yeah, developers write that. But they optimize for different things, such as payload size, right?
Uh-huh.
If the name of my property is 26 characters long, and I'm using JSON as a payload, that's 26 characters over and over and over and over and over and over in the payload, right? So what if I shrink it to 3 characters? Well, now it's a whole lot smaller, and payload size does matter. Well, but now I don't know what XPQ means, right? What does that mean? So we have to translate that into a property that makes sense in the class that we create in the SDK. And then when we serialize, we convert it back into the small name that they used in the API. So you can't just take whatever's in the API and turn it into a good SDK. But good SDK depends on what's your purpose. If all I'm doing is writing a private SDK that just my company, so I have one team that's making a service and I have another team that needs to consume it, and that's the only use for the SDK, well then who cares if it's still named XPQ, right? You can just talk to that guy and figure out what that means. But if my purpose is to provide a convenience for all of my customers to access my service, well now that issue becomes very large, because every single one of my customers are going to wonder, what does XPQ mean, right? So they're going to have questions when they try to use the SDK. So writing a good SDK takes a long time, takes a lot of work. So how do you do that at scale for hundreds of services, and that you auto-generate the SDK? And that's actually where my primary work is on auto-generating the SDK. And you can't automatically generate a good SDK. So now you have to create a process, a whole toolset ecosystem that allows you to take an imperfect spec, create as close to a good SDK as you possibly can, but then allow custom code or humans to sort of interface with the generator, either at generation time or after generation time, to augment what the generator did.
Interesting. So, I don't know, maybe people could be scared of hearing that some of the SDKs are auto-generated or code-generated, but actually it's a good thing, right? Because it gives uniformity, and if it fails in a predictable way, and you can fix it, once. So this is a good thing. Has it ever happened to you that, I'm trying to purposefully avoid LLM AI discussion.
Yeah.
But it seems nowadays that if you don't talk about AI, anyway, let's try to avoid that. So you have a problem, you create an API, an SDK to fix the problem, it goes out, it goes well, good. And then a year, 2, 3, time passes, and the landscape changes, and people try to use that SDK to solve a problem in a different way, right? And it breaks, or it goes slow. There are some problems. So, how do you evolve an SDK? When do you evolve an SDK?
Yeah, I think evolving an API or SDK are kind of go hand in hand as far as when you evolve it. But the simple answer is you evolve it when the product needs change, right? There's maybe on your first iteration of the storage service, it didn't have the ability to have backup, but now it does. And so we need to add a parameter to enable backup. You probably have a bunch of other settings. So these are very simple product-driven evolutions. Sometimes there are pretty major changes in the way that the back-end service works. And then you get into breaking change rules, which every company is going to have a slightly different approach with this. But in general, you should never break somebody. So there are certain things that are breaking. If I take a required input parameter and I remove that parameter, that's a breaking change, because somebody have written code, that code is running in production, it has no issues whatsoever, and then all of a sudden I change my service and now I'm passing in a parameter that I get back a 400 because it's a bad request because that parameter is no longer expected. So there are ways to do this that make it non-breaking, and there are ways to do it. There's the API level break, and then there's the functional level break that you have to take into consideration. So when do you evolve? Whenever the service has needs to change, but you also have to take into account what is the impact on all of your customers.
Do you have any anecdote on users using the API or the SDK in a completely unexpected and unwanted way that you say, oh, if you knew, you would have done something maybe different?
I don't know that I have any good anecdotes on that. There have been, when you're designing the API patterns for the SDK, you always have in mind what is a customer going to write, like how are they going to use this function or how are they going to use that function, and you try to name things and document things to guide them towards sort of your way of designing it. And I've seen code where I would have never written it that way. And yes, it kind of works, but it doesn't take advantage of some mechanism that we provided, and that it always, the first thing I always think of is what could I have done in the API shape differently
To prevent that.
to prevent it, right? And it's almost an unattainable goal, because there's always going to be somebody who maybe they were just going very fast that day and they didn't bother. It's not like you can solve all of it, but it's always something that I just immediately go, what could I have done in the API shape? So I think that's mainly what we've seen is people that just write it in a different way. I'll give you one example of this. We have a pattern called long-running operations. These are operations that take, let's say, anywhere from 10 seconds to days to complete. And so HTTP obviously is not a good protocol for this. Usually you want your HTTP request to be handled in milliseconds timelines. So what we do is we have sort of a start API, and you get back a token that allows you to then poll to determine the status, and then finally you get your final result at the end. And so we built an API that sort of wraps all of this together. So when you call, so a good example of this is in the virtual machines, you can reboot them, right? So this is going to take some amount of time. It's not going to happen in 1 or 2 seconds. So the method is still just called reboot. But we provide the object that you get back has a status on it, and it has an update status, and it has another method called wait for completion, which does the loop for you, right? So that's kind of the simple API where you don't have the control, and the check status and update status are the more complex APIs, because then you can control your own polling. So like if you're rebooting 10,000 machines, you don't want all of them pinging nonstop, right? Because you'll just eat up all your resources on your machine. So this API is designed this way, and when you make the reboot call, you pass in a flag that says wait until, it's an enum named wait until, and you either do .started or .completed. And I've seen a lot of times people will make the API call with .completed, and then immediately after that they'll do wait for completion, which is technically a no-op, because the object is smart enough to just understand that, oh, I'm already completed, let me just return. But those are the kinds of things that's like...
Why would they do that? You know? You don't know? You don't know.
No, it's lack of documentation, an intuitive API. You know, I always go back to what could we have done differently in this API that such that they would have known that they didn't have to do that, you know?
Oh boy.
So it's things like that. And usually these are customers, I usually find these, there's not an issue written about this. There's some issue and they give us snippets of code. And I'm reading all the code for context, and I find these things, which is separate from the thing that they're pinging me about. But I just can't help it. What is happening here?
Yeah, people use tools in a strange way. I remember when, I was in charge of a distribution of Redis for Windows, and this company, small insurance company called, it is slow. Your product is slow. Okay, let's take a look. It's like, I think I have a lot of data, a few gigabytes, and then we go, I said, what are you doing? Oh, just small payloads. We do small gets from the memory cache. You sure? Yeah, okay. And then we go, we see the commands they actually run, and they were taking all the objects of the cache. They would do a get with a star to the client, and they would search for what they were looking for in the client. I said, but these are very slow. You do the math, it would take about 2 or 3 of those commands to saturate per second to saturate the bandwidth. And they were doing like 1.8, 2 per second, plus all the other traffic. And they didn't know. They didn't know. So anyway, it took a little bit to fix, but
and that's a lot of the things you see is if you were to just use the same APIs, just use it this way, then you'll get better performance or better whatever. And it's how do you drive, and this is one of the things that goes into a good SDK, is how do you guide people towards the pit of success?
Yeah, because you never know if their lack of time or will to read the documentation,
right,
or if the documentation not good enough,
exactly,
or maybe you just need an AI to guide you through the documentation and find the right path.
By the way, no one reads documentation. That is one thing I've learned. No one reads the documentation. They look at IntelliSense, and so most IntelliSense tools use, like in all languages, have some sort of doc reading, but it's always the summary or like the one little sentence, because it needs to fit in the little hover pop-up. That's 95%. Just look at that, that's it. So if you can't fit it in there, no one's gonna know.
But you cannot fit patterns in there, right?
Exactly.
More complex things.
Exactly.
Like,
So you need to be very thoughtful about the name of the functions and the return types of all of those things really matter in order to guide people to the right direction. Otherwise.
So you also take that into consideration when you write an SDK, the first 2 or 3 lines that are going to be shown in the IntelliSense?
Yes.
Or the first, how many lines do they show usually? If you
so
mouse over a function.
I mostly work in .NET. .NET will show the entire summary.
Okay.
So in the XML docs for .NET, you have your summary and your remarks and your blah, blah, blah. It will show the entire summary. So if you write a paragraph, it will start to fill up the screen, which is also bad. So you want it to be short.
concise,
Yeah.
but still relevant. And,
Yeah, it will show the whole thing. Other languages and IntelliSense, I don't know if they make different decisions there, but
so does AI read your summary and remarks when they
Yeah.
look at the code?
yeah, of course, AI is watching everything.
Do they send you an email with comments and say, "Hey, Mike, please next time"?
I constantly type into Teams randomly to different people. I say, I for one welcome our robot overlords because I know they're listening. And when the takeover happens, I want to be on the right side.
You are how do you say that in English? A collaborator.
Yes,
a
I'm willing,
friend
I'm
of
willing
the
to
power.
work with you. Yes.
Okay. You think can we still talk about SDK and API without talking about AI in some way? Any other topic we can cover that you think relevant?
I think if you're trying to figure out should I write an SDK and if so, how should I approach that? It really comes down to how many customers do you have that need to rewrite that code to interface at the HTTP layer. They can do it, of course, but how many of them are having to do that? And that's really the biggest driver. What I think people will find is that if there's a lot of those, the community might pop up their own version of the SDK, but that may not follow your standards. And especially when it comes to like breaking changes and backwards compatibility and just the quality overall. And now you have this thing that's out there in the wild that's representing your company that you didn't write. So there's a lot of drivers for like going down that path and making sure that you have a quality SDK that represents well the service that you're putting out there. The next question you have is auto-generate versus handwrite, and that's just comes down to resourcing question and what you have available. There's a lot of auto-generators out there that will generate something, and then where a lot of generators start to fail is in that ability for a human to work in conjunction with the generator. So how do the generator's creating a certain pattern, how do I tell it that in this one case, do it slightly differently? And how do I do that in the least amount of code? And how do I do that in a natural way?
In a programmatic way, because I don't want to do that manual, because next time I auto-generate, and I want to click the button and do minimal or zero.
So how do I do that in a natural programmatic way that's repeatable? Repeatability is very important. And it can't be overly verbose, right?
Yeah.
It just rewriting that whole class so that the generator stops writing the class is, I mean, maybe that works, but it's very verbose if all I want to do is change one line. So those are, I think, some of the things that you start to run into, and obviously scale of how many customers you have will sort of determine and dictate how many resources you have to spend.
So we talk about SDKs, so easily and nicely write or access a service via your favorite language, or directly with HTTP REST, right? Do we want to spend a few words on the people that are using, SOAP, XML, all those technologies from the past? Can we say they're past? Are they gone? Are they dead?
They're not all gone. We have a couple Azure services that use XML still, that were written quite some time ago and still offer XML as a payload. The SDK we write for them is basically identical. It's actually good if a novice user can use the SDK for the service and not know or care what payload or protocol is used underneath the code.
But is there any reason today to write a service not using HTTP REST, XML, SOAP, all these other?
There's a lot of like webhooks and stuff, HTTP. There's AMQP protocol that we use for some of our stuff. There's a few different protocols that provide a few different advantages that you may want to use versus just straight HTTP requests. There's XML versus JSON. I mean, that debate's been out there forever. I think that JSON has won. There's really I don't know of any new development that is using or choosing XML.
Probably not.
For any reason.
What is MKP? You mentioned
AMQP?
AMQP.
I don't know a ton about that protocol. I just know it's one of the other protocols we have in our Azure services.
So you mentioned other advantages versus HTTP. Can you list a few, or for that, or for another protocol?
Well, HTTP is synchronous communication. And so what if I want an asynchronous communication, or a push notification or push protocol versus a pull protocol? So like if in the long running operation example, I ask you to start the operation and then I have to keep asking you when you're done. So I think those are the areas where you might start to go away from HTTP.
Okay.
But it's the over vast majority. It's like 99+% are just HTTP.
Yeah.
That
makes sense.
Yeah.
So at this point, I'm required to ask how
I'm required.
I'm required.
Okay.
by the producer, how AI is affecting your day job, either your code generation or your coding or anything else in the API/SDK world.
Yeah, I mean, we could go a lot of different ways with that, because we can go the generation way, which I think is very interesting.
We don't need to be politically correct in this, right?
Yeah.
So.
So when it comes to auto-generating SDKs, like I said, the spec is usually not written in such a way that you will get a deterministic good SDK out the other end. And by the way, the problem gets exacerbated when you want idiomatically good across a set of languages. Because what might be good in JavaScript is not necessarily good in .NET. And that also may not be good in Java. Like, they all have their different rules for what makes a good API. And it's very idiomatic to that ecosystem and that dev culture for that language. So even if you could get a perfect spec for Java, it doesn't mean that it's going to generate into JavaScript or C# in a good way. So you have this human interaction, right? Interfacing with it. And so the question is, can the AI replace that part of it, right? Or maybe replace the whole thing, but at least...
Replace the human, or replace the interaction between the human and the...
Generator.
Yeah. The second one.
The second one, yeah. Or maybe just replace the whole generator, but basically eliminate the need for that human, because all the human is doing is looking at that and saying, oh, well, this method doesn't make sense, or maybe the parameter should be named count instead of number of things, right? This really long name, it's just a count. Like there's things like this. And can an AI learn those same patterns? Probably. But the problem with AI, as it exists today, is that it doesn't give you a deterministic answer. And I don't know all of the exact technical details behind the scenes, but basically what it's doing is there's a probability set of whatever the next token is, and it's not always choosing the most probable, it's choosing somewhere in the top, and then it's re-asking the next question for the next token, So it takes a slightly different path through the tree and sort of generates something. It's always picking amongst the most probable so that it remains mostly correct, although we all know that AIs lie or hallucinate or whatever word you want to use. But it's taking.
Don't say lying, because when they will take over. It's like,
yes, I welcome our robot overlords. So it takes this different path, and so you ask the exact same prompt to the AI multiple times, you're going to get a different answer each time. It's all relatively generally the same. So when it comes to English, that's fine. When I want to craft an email to my boss because I want a promotion, right? Like that, it's fine that it comes up with a little different one, because that way they don't know that I asked the AI to do it for me. But when it comes to code, that's not fine.
No, it's not.
It totally changes the code. Like the method signature can't change. It's a backwards compatibility issue, right? It's a breaking change. So that's actually one of the
But there
biggest...
could be put safeguards, right, or guardrails to force the behavior. Maybe there will be another agent that would say, "Hey, look, dude, you cannot change the signature. You cannot change that. Last time you said that. This time you say this. I prefer the other way."
Yep. Okay.
Systems of agents.
Yep. No. So you're going exactly where we have already tried. So
multi-agent.
The other thing is the API. So let me just give one other aspect of the API before I jump into that part of it. So it doesn't know the patterns and standards for your company. So you might have a pattern that says all of the path parameters must be sorted in the front of the parameter set, and all of the query parameters must come last, right? I'm just making up an arbitrary rule, but that's your rule for your SDK, and every method follows the rule, and it's a pattern that your customers get used to. Patterns are good. Consistency is good. So the AI doesn't know this. The AI is basing it off of, again, probability based off everything that's read across the internet. Well, it's reading all kinds of companies' stuff, right? So one company might
give
be...
it a prompt.
Okay. So this is the
I studied a
second... You're jumping ahead. So this is the second problem with AI. Is one, you don't get a deterministic answer.
Yes.
And two, you don't get the standard. So, well, now, what if you say, in your context, you say, okay, here is the standards that I've written, which we've all seen coding standards. They're usually mostly complete, but they're not always 100% precise and complete. So that's problem number one. But you give it, let's say you do have this coding standard. So you feed it, here's your coding standards. And then you say, now build an API. And what it will do is it will generate something that is closer. And because, again, and I'm inferring here, I don't know exactly what's happening under the covers, but it's doing this tree walk thing where it's not always following one path. So sometimes it listens to the standards, and sometimes it listens to the fourth probability of the fourth token in the probability list, which is not in your standards, and it starts to go down the wrong path. So now let's say that your API has 10 functions, right? And without the standards and the prompt context, it just generates 10 that are incorrect. And now it generates 6 that are correct, right? You're like, great, we're closer. Now, the fun part is you can give back the same answer to the API, to the AI, and the standards again, and you can say,
do a better job.
You could just say, did you miss anything? Like, it literally, you can be passive aggressive with it because they're not in control yet. And what it will do is it will go, oh, sorry, I missed one. And now it has 7 correct. And then you say,
it's converging.
Did you miss anything? And now it has 8 correct, but one of the ones that was correct before is now wrong. and it picked up new ones that are correct. And you can just keep doing this over and over and over and over and over. And eventually, sometimes you end up with alt incorrect. But now you have to have, now it's not, you're not just saying, hey, generate this thing for me using these standards. You now need a whole validation layer to know when to stop the loop. And API AI requests are quite expensive, so you're spending money for each one of those API requests that you're sending in. And we haven't even touched determinism yet.
Oh, we have touched it.
No, because now you throw in, okay, here's the standards. Here's the last thing you did. You can't change any of the API shapes. And again, it'll get some amount of them correct. The code inside the function can still change, because all you've said is the API shape needs to not change, right? And then you have, well, what if the spec did in fact change? There is a new parameter for one of the methods.
Yes.
Right? So now, how does the AI know exactly what is possible to change and what's not possible to change? Can I add a parameter in the middle of the set? Does it always have to be at the end of the set? Well, depending on what language, maybe the rules are different for backwards compatibility. So it's one of those things where there's so much promise in that area, but we're just so far off from having anything that would actually replace even a portion of the workload that an SDK author has. What's interesting that we are having some promise with is to to use the AI to create the test suite for the SDK. That is a little bit more.
It seems, yeah.
That is closer. A little bit easier to deal with the slight fluctuations in the parameter sets in code that don't have a functional change on the outcome of the test, but would have a change on how backwards compatible version 1 to version 2 is.
Yeah, it's fun that you say that it's not close, because I would have thought that in this area, code generation, at the end you're going from English language to another language, it would be closer. In my world, so in memory databases, massive multi-threading, 3D code, it's not there. So you cannot have high quality code in complex scenario, obviously, production scenarios, and probably because the AI has been trained with what's out there, right? What's out there on Stack Overflow, among other places, and you don't see a lot of high performance code or very specific niche code. So I've found that the Copilot is very good at detecting the patterns within my code base, even if they don't exist anywhere else in the world, and giving me good autofill prompts as I'm writing code. So in the generator, we have an expression language where you can kind of put together a bunch of statements and expressions that then get serialized out into actual .NET code. And the expression language it's not out there anywhere. No one else would have used it. It's just in our code base. And as I'm typing out, for dot, int I dot whatever I'm building for the expression, it figures out how to autofill that. And that can only be from scanning my code. So I think it does well whether there's a lot of stuff out there or just local. I think it's more the repeatability of the pattern. And when you do a lot of stuff with, massively multi-threading and stuff, there's not a lot of patterns that repeat. It's very niche to this one function I'm writing or this one. Well, it is. even when we were dealing with 3D transformations or besides simple transformations in color, for example, in textures or intersections of lines, you wouldn't do that.
How are you invoking the prompt? Are you just relying on autofill as you're coding?
No, I was not allowed to do that. So I was on. I would take an excerpt, a snippet. I would go to, I would change the names there. Go to ChatGPT 4 or whatever, and I would ask.
Okay. So.
But also would ask like, okay, I have a line, I have a triangle. How do I write in space? I need to write a function that returns me the intersection line if it exists between two triangles, or empty set, and it will take that. Intersecting two triangles, you would think that in space it's not.
I have a suspicion that Copilot's magic is in the prompt engineering and what they put in the context window. Because in ChatGPT, if I ask it just a general question, I get back usually an okay answer. But if the first thing I say is you are the top .NET developer in the world, and then I ask the same question, I get a better answer.
Oh yes, I do that. I try to do that.
Yeah, and so
it limits the context that it
I don't know.
Considers.
I think it has an ego.
You think it has an ego? You are not going to do the well.
Which is totally fine with me. It's okay if it has an ego, but I don't know. I wonder how much is in that context window that Copilot is doing that makes it perform so much better than just trying to put snippets in ChatGPT.
Yeah.
But I know Copilot is, obviously that costs money versus ChatGPT is generally free if you just want to use ChatGPT 4. So a lot of places don't have Copilot. We luckily have access to it, and it's just so much better than putting a prompt into ChatGPT.
Yeah, I believe that.
And it has to be. There can't be any more magic unless they have their own LLM that they run against, but I don't think they do.
Copilot? Probably they were going to use ChatGPT, right? I mean, it came out very soon after. Yeah.
I have no idea. I thought that they were just using ChatGPT. They might have a specialized LLM, like a fine-tuned one that. But either way, it's not. I think a lot of the magic is in that prompt because I get such dramatically different answers by just putting something as simple as, "Hey, you're a really good developer."
So can we put out a disclaimer? Okay, so we are not against AI, right?
No.
We consider it a tool that might be getting a little bit too much hype, might be getting too much too high expectations.
Yeah.
AI might not be the right name for that, right? Because it's not intelligence.
So here's my hot take on the name and the hype. And when computers first came out, well, it's not when they first came out, but at some point in time, the interface to the computer was punch cards.
Mm-hmm.
So you had to know like how to punch them, and then you had to know how to read them, and we made readers and stuff, and that made it simpler. But like if you didn't know how to deal with that interface, you weren't using computers, and so the scope of people that could use it was like this, right, tiny. And then we came out with command line interfaces, and this was like a leap into the future, like.
Yeah.
The amount of people that could now use a computer went to a much, much, much larger set. But it's still small relative to the whole population because most people don't think in those terms and remember all the parameters and, know how to interpret the results and stuff like this. So then there was another major leap into the future, which was graphical user interfaces. And now people can click buttons and they can just drag a file from this folder to that folder, and they don't have to type move blah blah blah, and I missed a slash or something. So the amount of people that can now use computers is like so much larger. And all of these copilots and everything is just a natural language user interface. There's nothing intelligent about it. But now let me finish before you explain why I'm wrong. Now I can just say, hey, look at my emails and tell me if there's any tasks that I need to do for this week, right? And could I have done that myself? Yeah, I could download those files. I could run some queries against them and extract out that stuff. And I can I could have done all those commands, just like the GUI changed the number of commands I had to type to now just a drag and drop. Well, now I can just sort of tell it that I want this to happen. And you figure out all the stuff underneath the covers, because I don't know how to do it. And what we're doing is we're sort of expanding how many people can start to use these things. Look at how many developers can now develop way more than what they used to be able to do, because they can now just use their natural language to say, I need a function that does this. And they get it. That's my hot take. There's nothing intelligent about it.
I disagree, but not full. It's a complex. It's an interface.
Like I said, it's my hot take.
It's an interface. Okay, we agree that it's an interface, but now you're saying it's not intelligent because it's just an interface.
No.
You're saying, because behind the interface there could be some intelligence.
I
don't think there is now, but there could be, right?
Yeah. The reason why I don't necessarily see it as intelligence is just a probability picker.
Oh yeah.
It has some tokens, and all it wants to do is what is the probability of the next token, or what is the most likely next token, and then it asks again, what's the next token, the next token, the next token, right?
It's a neural network, but on the other hand, also our brain is kind of a neural network, and we don't really know how it works. So the question is, can that neural network, digital, grow at some point and become aware, intelligent, or or not? And
so what are the tests that are necessary to know that? What test could you run such that you would say now it has intelligence?
I don't know if you can run a test, but if they take over, probably they are going to be intelligent.
Well, but okay, so what observation would you need to see in order to say now that has intelligence?
Take over.
Okay.
An entity that says,
okay,
please translate this spec to this code and do that 10 functions, what you were saying earlier. And they say, you know what, screw you, and they go out and they take over
so I'll tell you my test.
Costco and then Whole Foods, and then they take over the city. Yeah.
So basically what you're saying is that we have zero time between figuring out that, they are actually intelligent now, and them taking over. There will be no window of time where we could sort of unwind.
They are faster, they might acquire resources, digital resources, they might, I don't know, they might be accumulating in Bitcoin as we speak, I don't know.
I think one test that I like to do at work is whenever, manager or someone asks me to do something or tackle some problem or whatever, I just take whatever they said and I put it into ChatGPT and see what comes out. And I am very comfortable in my job.
Yes.
Because to me the intelligence is distilling what it is they're after into how could we accomplish this. And unless the AI has seen this problem occur, they don't, or unless ChatGPT has trained off of this kind of problem, they don't know. So that's not intelligence. That's to me, it's like, I can I can train my dog that when they hear a certain noise that there's a pheasant in the bush and that they should stop and point at the bush. Does that make them intelligent, or did they just learn?
Trained.
Yeah.
So we kind of
It's
agree that.
reasoning is kind of where I think the leap is there.
So do you think that intelligence is being able to solve or to try to solve problems that you've never seen before? Can we characterize that as one feature?
I don't know
of
if I would
intelligence?
define it that way, but I think that is an observation that if I made that observation, I would believe more that there is
than the other one.
intelligence. Yeah. So because I don't know that I know enough about the space to even begin to come up with a definition. But certainly reason is a thing that has to be there, right?
Yes.
And there's another observation that I think if it was intelligent, it would be able to demonstrate, and that is I can ask it a question, it'll give me an answer, and sometimes it's just completely the wrong answer. Now you might say that that's not intelligence, it's just uninformed, right? Okay.
Yeah.
So then I tell it that answer is wrong, and it says, oh, sorry, which it's just hard-coded to say sorry when you tell it it's wrong, and it goes, here's the actual answer, right? And an intelligence would not give me the same answer that it just gave me in different words. And that happens all the time, where I just told you that that's not the answer, and now you're telling me that that's the answer again, after saying, sorry, here's the right answer. So like that's not a demonstration of intelligence. And then another one is I'll ask it a question, it will give me the right answer, and I will tell it it's wrong, and it will say, oh, sorry. And intelligence would go, no, I'm right. Here's why.
Trust me, I know.
Well, or here's the data, or here's the whatever.
Yeah.
Right? How many conversations have you ever been in where somebody says the right thing and you tell them they're wrong, and they just go, okay, sorry. That's just not how it works.
Usually, it's the opposite.
Yeah, usually even when they're wrong, they're like, no, I'm right. So, I don't know. Those to me are things that are missing.
So we are safe. Our job is safe. Our jobs are safe for now.
My job is, because again, I take what I've been asked to do, and I just put it in ChatGPT, and yeah, it doesn't know what to do.
Well,
once I distill it down into, okay, I need this little thing, then it starts to get a little better.
So this seems a good place to finish.
Okay.
And we are safe for now and everything. But just in case, let's remind our robots.
I welcome our robot overlords.
Thank you, Mike.
Thank you.